In the previous video that we had, we looked at the characteristics of the planets, kind of one by one listing them, and split the planets into two groups. In this video, we're going to look at the characteristics of those groups of planets. These are some pictures of the solar system. You may see some things you recognize here. And we'll look at a few pictures like that. These aren't in great resolution, but they're okay. This is a picture showing Earth and Mars side by side, so you can get a feel of the relative sizes of the two planets. And we'll do some other things with that too. A few years ago, there was someone who made these models of the planets in the solar system, and they were to scale and accurately drawn and things like that. So you can see here Earth and Venus are pretty darn close together size-wise. Mars and Mercury are a bit smaller, and then Pluto is smaller than Mercury. Up until 1978, astronomers thought that Pluto was probably larger than Mercury. And then in 1978, they discovered a moon orbiting Pluto and realized that it was much less massive than Mercury and the smaller planet. Here are the Jovian planets, Jupiter, Saturn, Uranus, and Neptune, and you can see the four terrestrial planets and Pluto down there, that they are definitely in a whole different class. And we'll be looking at the characteristics of the two groups of planets here. And then you toss the Sun into the mix, and it dwarfs even Jupiter. First, the Jovian planets, the Jupiter-like planets. Their characteristics. It includes Jupiter, Saturn, Uranus, and Neptune. Jupiter is the prototypical Jovian planet. And they all have large masses and diameters. They have low density. An average chunk of Saturn would float in the bathtub. And the reason for that is that most of them is made up of their atmosphere. They have faster rotations. And this became obvious to me back in 1994. There was a comet called Shoemaker-Levy 9 that was orbiting Jupiter. This is actually just a picture of Jupiter, and that black spot is the shadow of one of its moons. This was comet Shoemaker-Levy 9, and it was a comet that had been split into a large number of pieces. I can't remember, somewhere in the order of 22 if I remember correctly, but it had been discovered by Carol and Eugene Shoemaker and David Levy, and they started studying its orbit and realized that instead of orbiting the Sun, it was orbiting Jupiter. This happens occasionally. Jupiter is so massive that at times it captures comets, and that had been the case with Shoemaker-Levy 9. And on one of the previous orbits of Jupiter, the comet had passed so close to Jupiter that the tidal forces from Jupiter had actually torn the comet apart. When they studied its orbit further, they realized that in late July of 1994, it was going to hit the planet. People all over the world aimed telescopes at it to learn about this. And there started being reports out on the internet, which was fairly new in those days. People said that they could see the impact sites through telescopes as small as 4 inches. So one night we took a couple of the school telescopes and set them out on the parking lot, and we're looking at Jupiter through the telescope. We couldn't see any impact sites through those, so we looked at other things for a while. And then someone said, "Hey, I think I see something." And sure enough, one of the impact sites had rotated into view. And we watched for a couple more hours, and the rest of them rotated into view. In 5 hours or so, Jupiter will do half a rotation, and so all those things that were on the far side of Jupiter rotated into view, and we could see those impact sites. These were quite a sight to see. So they have faster rotations, the Jovian planets do. They have long orbital periods, their revolutions, because they're far from the Sun, and they're widely spaced. Remember, the 4 terrestrial planets fit in a space of just about 1.5 astronomical units, and the Jovian planets are widely spread. None of the distances between them are as small as 5 astronomical units. They have many moons, and all of them have rings. Now, Saturn is the only one that's known for its rings, but the other planets have rings as well, and they've been discovered by other means. Some of them we had to put things in orbit around them to see the rings on them, like the Jovian rings, the rings around Jupiter. Saturn's you can see pretty easily through a small telescope. Here's a few nice pictures of Saturn's rings. These were taken by the Cassini spacecraft, which orbited in the Saturn system for several years. However, here are rings around Uranus, and you can see some of Uranus's major moons there: Titania, Umbriel, Miranda, Puck, Portia, Ariel, and Oberon. This was photographed in infrared light. The rings show up easily in that, whereas in visible light you would not be able to see those rings. Can you guess the naming theme for the moons? And here's a hint. If you've taken a Shakespeare class, you might be able to. Okay, so they all have rings. They all have deep atmospheres. They're mostly gas, and they don't really have a surface. That's why their densities are low, because they have such deep atmospheres. Whereas the densities of the terrestrial planets, our atmosphere is like thinner than the skin on an apple around the rocky core of the planet. They have strong magnetic fields, and so that's something. It takes moving charges to make magnetic fields, and something that has some charge to it moving around. And in the Jovian planets, they're mostly made up of hydrogen and helium, and when that gets a certain density, the hydrogen begins to act like a metal and conduct electricity, and so that can move around and create magnetic fields. The Jovian planets can be subdivided. Jupiter and Saturn, almost entirely hydrogen and helium. Uranus and Neptune are referred to as the ice giants, and they're still mostly hydrogen and helium, but they have ices of different types. CH4 is methane. That's a particular molecule and can be formed into ice. Ammonia can be frozen, NH3 there, and then H2O, that's just plain water. That's one of the ices that can show up there. Okay, then we have the terrestrial planets. These are the Earth-like planets, and pretty much you just take the characteristics of the Jovian planets and turn them around. They include Earth, Venus, Mercury, and Mars, small masses and diameters, mostly rocky with high densities. They have slower rotations. In fact, Venus takes practically forever to rotate, but it's been locked into its rotation with the Earth by the gravitational force of the Earth. And then Mercury has been locked into its particular rotation by having that gravitational resonance with the Sun. Shorter orbital periods, near the Sun, closely spaced, few or no moons, and they don't have rings, and thin atmospheres or none at all. Earth's atmosphere we think of as fairly substantial. We've got a radius of 4,000 miles. That's the planet radius for Earth, but the atmosphere, by the time you're up about 20 miles, you're above almost all the atmosphere, more than 99% of it. So that's a pretty thin atmosphere, 20 miles out of 4,000. So not much to it. Mars' atmosphere is a much lower density, but similarly thin. Venus's atmosphere is very dense, but it's also thin, and so there isn't much to it. Mercury doesn't have an atmosphere, except the side facing the sun will have a few things that basically evaporate off when during the long days on the surface of Mercury, but then they freeze back onto the surface during the nights. So thin atmospheres or none at all on those things. So those are the terrestrial planets. Then, what about Pluto? That used to be considered a planet. Well, let's look at some small objects in the solar system. Here's the Earth. These pictures are all to scale, and you can see the Earth's moon there. Pluto, which is smaller than the Earth's moon. It's only about 2/3 the diameter of Earth's moon. And then a couple of things that were discovered in the 1990s and early 2000s. And these are objects that are out beyond Neptune in the solar system, and more objects were being discovered out there in the 1990s, and they have been ever since. So Quaoar and Sedna are things out in that same part of space that Pluto happens to be in, beyond Neptune. Then here's going from Earth on down for solar system objects. And Venus is the next smallest object. Mars is next. And then you get to moons of the solar system. Ganymede, Titan. And then Mercury is smaller than Ganymede and Titan. Then Callisto, Io, moons of Jupiter. And then Earth's moon. And then Europa, another one of Jupiter's moons. And then Triton. And then you get to Pluto. And so Pluto is quite a ways down the list. And so for that reason, maybe it doesn't belong into the terrestrial planet catalog, and its density that really kicks it out of that it's so much less dense than that of even Mars, which is the least dense of the terrestrial planets. And then the region that they called these things out beyond Neptune was called the Kuiper Belt. They're also called trans-Neptunian objects, things beyond Neptune. In 2004, actually I think it was a year or two after 2004, Eris was discovered out there. And Eris is almost identical size-wise to Pluto. It's a tiny bit smaller, but it's actually a bit more massive than Pluto. And it was the discovery of all those things that ended up getting Pluto more or less demoted from being a major planet or a planet to being denoted as a minor planet. Eris and all these other round objects on there are considered minor planets. Those are things that have enough self-gravity where it's crushed the planet into a roughly spherical shape. When Pluto was sort of knocked out of the planet category, there were lots of cartoons about it. This was one of my favorites. You may not know who Paris Hilton was, but she wasn't a gifted singer, or isn't a gifted singer. We'll stop here and consider the other solar system objects in another video.